right, today we're going to be multiplying and dividing rational expressions. So let's just review what we know about multiplying and dividing fractions in general. So for multiplying, you're just going to factor everything, all right? Multiplying fractions is no problem, top times top and bottom times bottom. So just multiply straight across, nothing about a butterfly, just top times top, bottom times bottom. Remember to note any domain restrictions that you might have, and then, of course, simplify. It would help if you factor top and bottom first, and then when you're multiplying, you're just multiplying everything. You're just setting your factors next to each other. So that's how you multiply. In order to divide, we're going to factor everything, right? And then make sure you note any domain restrictions. For this one, it's a little weird because we are going to keep, change, flip. So that means keep the first fraction, change to, so let's see, keep the first fraction and then change it to multiply, and then you're going to flip the second fraction, okay? So because you're flipping a fraction, your domain restrictions, you're not allowed to have a 0 in the denominator. So you can't have one here or in the original denominator before you keep, change, flipped it, right? And then once you flip it, you now have a denominator here. So you're not allowed to have any domain restrictions here. So let me do this again. Here, here, or here in the original problem, okay? So keep, change, flip, and then multiply straight across, top times top, bottom times bottom, okay? All right, so as I'm looking at this problem, I see I could probably simplify before I multiply, right? Because if you multiply straight across, we're still going to have to simplify our final answer, so we might as well simplify early. I see 4 and 12. That can simplify to a 3 on the bottom, right? I've got a y on top, y on bottom. I've got some x's on top. I can take 2 from the top, so that would leave an x squared here on the bottom. I don't know, let's see what that does. So now I just have 7y on top, and I have 5 times 3 would be 15 on bottom, and then an x squared. Yeah. All right, that is our answer. Let's see what happens though if, what if we didn't do that? What if we just multiplied everything? 4 times 7 would give us 28, and then we'd have an x squared, and then y times y would be y squared, yeah? And then on the bottom, we have 5 times 12 is 60, and then I've got x to the 4th and y. All right. 28 over 60, we can divide by 4 on top and bottom. So that would give you 7 over 15. I'm still going to cancel out, let's see, 2 y's from the top. Actually, I've got 2 on the top, 1 on the bottom, so I can get rid of 1 on the top and 1 from the bottom. And then 2 from the top here and 2 from the bottom, so that'd be an x squared. So you would still end up with the same answer. So you decide, do you want to simplify it first or simplify it last? It's up to you. That's only for multiplying though, because remember on this one, we're gonna keep, change, flip. So you gotta flip it before you can start canceling things out. All right, let's try this one. I'm noticing things are not factored, so step 1, factor everything. Let's see, so factors of 4, that will add up to make -5. We've got our x times x, so I'm guessing 4 times 1, both negative. That would give you a -5, okay? And then on this one, same thing, we got a factor. X times x is x squared. Factors of 6, 2 times 3. Everything's positive. That would give you 5 in the middle. Okay. I do look to see in each individual fraction if I can cancel anything out, but no. So, all right, now we're gonna keep, change, and flip. So I'm gonna keep this one as an x minus 4, x minus 1 over an x plus 2. All right, and then I'm going to change from division to multiplication. All right, and then we're going to flip this one over, meaning the x minus 1 is now going to be on the bottom, and x plus 2, x plus 3 is now on the top. Okay, we'll go ahead and do that. All right, so that's keep, change, flip. Now it's a multiplication problem, and I can find things on the top and bottom that I can cancel out. So for example, I see an x plus 2 on the bottom, x plus 2 on the top, x minus 1 on the bottom, x minus 1 on the top, and that leaves me with nothing left on the bottom, so it's not a fraction anymore, but I have an x minus 4 and an x plus 3. So that's my final answer. And then if we look at our domain restrictions, I said that it can't be in a denominator, so it can't be here or here. And then once we flip it, this is also a denominator, okay? So that means our domain restrictions, it cannot equal a -2 for this one. It cannot equal a -2 again for this one. You don't need to write it again though. This one would be a -3, and then this one would be a +1. All right, so we just kind of go through those 3 spots and eliminate domain restrictions. Okay. All right, let's keep going. We got another keep, change, flip. We do need to do some factoring though first. All right, first fraction on the top, let's factor out an x squared. So that's going to leave an x minus 4. And then this one's good, this one's good, and then let's factor over here. Let's see, factors of 18, let's see, that give you 3. So that's going to be, what, 6 and 3? 6 times 3 is 18. Put the negative right there. Okay. So now we're going to do keep, change, flip. Keep, change, flip. All right, so we're going to keep our first fraction, x squared times x minus 4 on top. And then x minus 3 on bottom. All right, we're gonna change it to multiply and flip this one. So now I've got x minus 3, x plus 6, and then an x cubed over here. All right. So what can we cancel out? It looks like we've got an x minus 3, x minus 3. We've got some factors of x, so if I take out 2 factors of x here, that would just leave like 1 factor of x. So that would be 1 factor of x on the bottom, and then on top, x minus 4, x plus 6. All right, and then we don't have anything else we can cancel out. So then let's look at our domain restrictions. X cannot equal, let's see here, it cannot equal 3. All right, here, again, a 3. It cannot equal a -6. And then here, it cannot equal 0. All right. So there we go, that's our answer. All right, let's keep going. All right, we got multiply, so we're just gonna multiply straight across. Let's do some factoring first. First fraction, I can factor an x out. So that's going to give me x minus 3. Second fraction, that's going to be a 2 times 3, but put the negative on the 2. All right, there we go. So when you simplify, let's see, if we just write it out what we have an x times x minus 3, and then an x minus 2 on top. And then we have an x minus 2, x plus 3, and then an x on bottom. So I've got an x minus 2 on bottom, x minus 2 on top. I have an x and an x. So I don't have a denominator anymore. That means I no longer have a fraction. So I have an x minus 3 on top and an x plus 3. There we go. And then my domain restrictions. I'm just not allowed to have x's in the bottom. And we didn't flip anything. So it's just these two places. It's just these two places. We're going to have x cannot equal 2 or 0. All right, we got one more problem to do. It's division, so we're going to do keep, change, flip. And first we're going to factor everything. All right, first we're going to factor everything. So let's see. This one is going to factor, let's see, 4 times 1. But we got to put the negative on the 1. All right, and then this one is going to factor to 2 times 2 to get the 4 in the middle. This one is going to be a GCF. We're going to factor out a 2x, so that's going to leave x plus 2. And then this one, to get a 3, it's going to be 3 times 1. Everything's negative. There we go. So factor everything first. And now we're going to do keep, change, flip. So I've got an x plus 4, x minus 1, and then an x plus 2, x plus 2. All right, and then change it to multiply and flip the second one. So I'm going to put my 2x, x plus 2 on top, and then my x minus 3, x minus 1 on bottom. All right, and then cancel out. Let's see, what do we have the same? I've got an x plus 2, x plus 2. I've got an x minus 1, x minus 1. I think that's it. All right, so in my final answer, oops, I've got x plus 4 on top. Oops, we'll put the 2x in the front. That would look weird. And then I've got an x plus 2 on the bottom and an x minus 3. Okay, and then domain restrictions. X cannot equal here. So we're going to call that a -2. And we can't have it here. So it also can't be a 0 or another -2. And we can't have any here. So we're going to call that 1 and 3. All right, there you go. All right, so for multiply straight across, and for division, do keep, change, flip.
Okay.
Okay.